Welcome to This Explainer. Today, we're going to explore together the absolutely mind-bending physics of space-time, dive into the life cycles of stars, and honestly, look at some of the most groundbreaking new images that have literally rewritten our understanding of the cosmos.
Section 1. The ultimate cosmic mystery. What exactly is a black hole?
To really grasp these things, we kind of have to completely throw out our everyday intuition. So a black hole is a region in space where matter is compressed into such a tiny space that the pulling force of gravity prevents even light from escaping, right? It's not just empty space, it's a massive amount of matter packed into an impossibly small volume. And it's exactly this extreme compression that creates that ultimate cosmic cloak of invisibility. Section 2. Bending the fabric of space, a new way to look at gravity.
So, to wrap our heads around this extreme density, we actually have to move past Newton's classic model, the idea of invisible pulling forces between objects. Instead, Einstein's general relativity asks us to view gravity totally differently. Think of space as a flat, stretchy space-time membrane, like a trampoline. You drop a heavy object, like a star, right in the middle, and it sinks. It curves the fabric around it. And that curvature, that is exactly how mass deforms space.
And this brilliantly illustrates the difference. Look at the space-time dip created by our sun over on the left. It's a relatively shallow depression, right? Light and planets can safely cruise along those curved grid lines in stable orbits. But look at the black hole on the right. It is infinitely deep. Those grid lines just plunge straight down past the event horizon and they never come back up. Not even light can climb out of a well that steep. Section 3. 3 types of black holes, from the atomic to the galactic. Now, black holes actually come in 3 main types. First up, we've got primordial black holes, which are thought to have formed right after the Big Bang, way back in the early universe. And it is literally mind-blowing to think about this. A primordial black hole packs the mass of an entire mountain into a space the size of a single atom. No way, right? Next, we have stellar black holes. These are born from exploding stars. They're tiny, maybe only 10 miles across, but they can hold up to 20 times the mass of our sun. And finally, the heavyweights, supermassive black holes. These monsters are roughly the size of our entire solar system and contain the mass of more than 1 million suns combined, forming right alongside the very galaxies they anchor. Section 4. Capturing the first image, the Event Horizon Telescope. Okay, this brings us to an absolutely monumental scientific achievement, photographing Sagittarius A star, the supposedly unphotographable center of our Milky Way. Now, this thing sits an astonishing 27,000 light-years away. To put that into perspective, trying to photograph it from Earth is exactly like trying to take a clear picture of a donut sitting on the surface of the moon. I mean, a single standard telescope just isn't going to cut it. So to pull this off, a massive global team created the Event Horizon Telescope, literally linking 8 radio observatories together to create one giant, Earth-sized virtual telescope. But, distance wasn't even the only hurdle here. As EHT scientist C.K. Chan put it, getting this image was a bit like trying to take a clear picture of a puppy quickly chasing its tail. Why? Well, back in 2019, the team photographed a much larger black hole called M87 Star, where the gas took days or even weeks to orbit. But the gas swirling around the much smaller Sagittarius A star, it moves at nearly the speed of light. It completes an orbit in mere minutes. So the brightness and the pattern of the gas were changing rapidly right before their eyes. The researchers basically had to invent highly sophisticated supercomputer tools just to average out all that frantic, chaotic data. Now, what's really interesting here is that when you look at the final results, we obviously can't see the black hole itself. That's the completely dark central shadow right in the middle. But notice that bright, glowing ring-like structure surrounding it. That's the accretion disk. It's made of spiraling gas that's getting heated up by extreme friction. And that friction releases highly energetic light, including X-rays, which our Earth-sized telescope was finally able to pick up on. Section 5. Dispelling black hole myths. Fiction versus physics. I know these awe-inspiring images can sometimes bring up a little bit of existential dread, so let's clear up some common sci-fi tropes and ground ourselves back in reality. Tell me if you've heard this one. Do black holes operate like giant cosmic vacuum cleaners, just aggressively sucking up everything in the universe? To figure that out, let's do a little thought experiment. Imagine if, right at this exact moment, we magically replaced our sun with a black hole of the exact same mass. What would happen to Earth? Well, surprisingly, absolutely nothing. Seriously? No way? Earth's orbit wouldn't change one bit. So the crucial point is that black holes follow exact physical laws. They don't just wander around purposefully swallowing planets. As long as you stay at a safe distance from that steep space-time dip we talked about earlier, you are perfectly safe.
And hey, speaking of our sun, you definitely don't need to worry about it spontaneously turning into a black hole anytime soon either. It simply lacks the massive scale required to actually collapse into one. Instead, billions of years from now, it's just going to safely expand into a red giant star, gently throw off its outer layers to form this beautiful glowing planetary nebula, and finally end its life as a small, cooling white dwarf. It's basically a very peaceful cosmic retirement.
Which really leaves us with this exciting, kind of provocative question. With groundbreaking images of two drastically different supermassive black holes now captured, one at the really large end and one at the smaller end, what new secrets of extreme gravity are we going to unlock next?